Good morning, everyone. Maybe a little more after what Clint started with there. I kind of approach all this from a real pragmatic standpoint, formerly being an application engineer and kind of being in the trenches with folks like you. And some of the best stuff I've learned, kind of on the job, working on different projects. And what I wanted to do this morning is to be able to share with you kind of some ideas, and maybe in 5 categories for you, to give you some ideas as you're approaching remote monitoring applications. And I know that's a broad term. Hopefully at the end of the session you have a little better understanding of it. I think you can take that in a lot of different directions. I hope that after the end of the session that all of you can maybe take back a little tip. So maybe if you're a little more advanced in terms of doing some of this, that you maybe pick up some tips on security. Maybe if you don't know anything about it, you can kind of take away a general perspective of it with that. Before I start, maybe show of hands, how many of you folks are working on remote monitoring projects now or in the next 6 months? A few of you? Okay. And I know it's kind of vague, when I say remote monitoring, we're kind of collectively throwing in SCADA, throwing in a little bit of that HMI on the plant floor and a couple things like that. So if you don't have a good feel for it, I guarantee after the session that you'll be able to understand a little more with that. Good. So let me get started, and I think we might have a little bit of time for questions at the end. If not, I'd be happy to talk with any of you in more detail out on the exhibit area after. So I think one of the fundamental challenges with remote monitoring is it touches so many different aspects, and this is kind of giving you a little bit of perspective on that you have to be a little bit of knowledge about the edge devices you're connecting, whether it's PLCs or RTUs or maybe VFDs. You got to know a little bit about communications, you got to know a little bit about IT and a lot of things like that. And on the surface, I think it can be a little difficult and bewildering when you look at it like that. But hopefully, if you feel that way after this session, you'll get a little better idea of how those parts fit together and how to maybe collaborate with some of the folks within your organization to accomplish some of the efficiencies and capabilities through remote monitoring that you can achieve with that. And I was kind of reminded, I did this session in Wichita, and was talking to a few folks after that. I thought it was really interesting. About 10 years ago, I think I was at a Wonderware user conference and started to see, the IT guys with the SCADA guys kind of working together as a team. And if anything else, that teamwork to be able to take different talents and work together, I think is a recipe for success in this space here. So let me move on a little bit, and maybe we could start off with the first tip. And there can be kind of categories for these, and with a couple little tidbits in there with those. So hopefully we can kind of take a look at a few things. Typically, when we talk about remote monitoring, I think the SCADA is probably the best example of this, right? You've got some field devices you want to collect information from, and you need to gather that. And probably the best example for that is, good old Modbus over here with which to do that. And some of you know a little bit about that, right? So when you're using Modbus, you have to ask a question, tell me the value of the tank level, right? And that request, kind of comes down through the system here and gets pushed out to the edge device. And then from the edge device, it replies and comes back up, right? So it's kind of chatty, request response. How are you feeling? Good. How are you feeling? Maybe not so good. Whatever that might be. When you look at this in a little more detail and look into it, what you'll find out is that you have a polling cycle to do these things, right? So you have to have a little time to be able to send the request. That edge device, maybe a RTU, maybe takes a little bit of time to respond to it. You have to send that back. If you're going over maybe an old SCADA radio system, it might be not the fastest. It takes a little bit of time to come back, and then maybe a little bit of turnaround time before we can ask the next one. So basically, with this type of architecture, you have to keep in mind that total cycle time, if it's maybe 1 second per site and 100 sites, now you've got 100 seconds basically to be able to get around and refresh those values a little bit. So real typical, of a Modbus type system for doing a polled environment. Well, polled is great, but there are some other ways to accomplish this. Let's take a look at some limitations first. The first limitation is the sequential processing. You have to go around in the loop and check everything that's happening, right? So that has implications from how many devices, how much information are you requesting from those devices, how long does it take for them to respond, what's the speed of the media I'm using. If I've got some old serial-based radios, not so fast running at maybe 1200 bits per second. If I've got a microwave link, a lot faster, and I can move video if I need to, right, on that one. How about some considerations on the data? What about if I've got some sites that I need to refresh the data a little quicker than others, right? I might have something where the process is a little quicker and I need to respond a little quicker versus maybe I'm looking at a tank level, and that tank level may vary every 30 minutes, right? So that kind of goes into consideration on this. And then lastly, and this is the one maybe in the last 5 to 10 years is kind of getting a little more interest, is wireless technologies. You know, amazing technologies we have at our fingertips now, but with these technologies, you know, there's some monthly operating costs that go with them. So when you're thinking about these systems and looking at these, you have to consider what's my month-to-month cost on this? And all of these are going to be usage-based. So when we look at these, we're talking about how many dollars per megabyte or whatever that is. And there are some ways to manage that, you know, in a large application, but there is a cost associated. And in a good system design, you know, you want to balance the system that you can basically take good use of the communications channel that you have. Okay, that's kind of how we are today. Now, how many of you folks are familiar with like report by exception type technology? Good, good. If you're doing some PLC work, especially with like Ethernet IP, this was actually introduced with DeviceNet years ago. Interesting technology. And it's neat to see that, you know, from the SCADA standpoint and HMI, that the OPC UA Foundation has started to adopt this a few years ago. And basically it talks about only send a change of state. So if I have a digital signal that goes off to on, only tell me when it changes. Don't just keep sending it every 10 milliseconds, right? Likewise, if I have a pressure and I want to sense a pressure and that pressure doesn't change, and I want to say if it changes by 1% or maybe 10 psi, I want it to send it. That's the basic fundamental aspect of this report by exception. So, and it's a little bit, you might hear the term, especially maybe if you're a little bit a younger engineer, you might have heard the term of push versus pull. The pull is the polling response. You have to ask for it and pull it out. This is more of the push response, report by exception. A couple things about this that I think are important to consider. When you can do report by exception, you can minimize your data transfer. You're only sending it when you need to, right? When that digital signal changes state, or you're sending it when an analog value changes state. The challenge is right now from the OPC UA standpoint is from the server to the client application, they're kind of doing it here. There's not a lot of adoption out at the device level, with the exception of maybe Ethernet IP might be a good example of that, but maybe not so good for wider area networks in a SCADA device. Also, I guess I didn't neglect this one. If any of you are working with DNP protocol in the power segment, sometimes in water and wastewater, DNP has a pulled mode as well as a report by exception mode, which can be pretty useful for some of those applications with that. Now there are some technologies, and I'll talk just a moment about Moxa, but I think you'll see this being used across many different areas in the next 5 to 10 years. We've called this our active tag technology, and we've basically taken that report by exception down to the field level. So in a SCADA application, you know, you will have a device out there that's able to collect that data, and then we use this in terms of an OPC server on the SCADA side with our connection here from device to OPC server, and that can do report by exception. So again, when the digital signal changes, we'll send the signal from the field device up to the server. If the analog value changes by, say, 1%, we can send that. Sometimes you might even want to periodically, maybe every 10 minutes, just refresh it, and that can be helpful when you have devices that go online and offline. And one of the nice things about this push technology, when you're working in an application that's very secure and have different compartments to isolate the different aspects of your wide area network, it works really nicely with firewalls, which typically prevent communication coming in. When you have this report by exception, the connections from here up through here. So if there's a firewall out here, it can make that connection out through the firewall, much like being in the office. You know, you can get out to go on the internet to do some research, but the bad guys don't get on your network from the outside with that. So interesting technology, and I think you'll see more of this. I want to go a little bit to, perhaps in the previous session there was a little bit of talk about this technology, and it's something that's not widely known yet, and I think it's something to kind of keep on the radar for what's happening. This is called MQTT. It had its foundations in pipeline monitoring, and actually kind of comes out of some joint work with IBM and a server-based approach from the IT standpoint. They have a technology called message queuing. That's where the MQ comes for. but they do this report by exception architecture. And just to give you a little glimpse of where we're going with this, you have the edge devices over here that are going to be the producer, if you will. You have a device called a broker that kind of arbitrates that. And just in simplicity, when you have a digital signal changes, it broadcasts that on a topic. The topic might be safety switch number 5, or it might be whatever that device name is. And then anybody over here can be able to read that on a report by exception basis. Fascinating technology, very much one of the things that's powering the so-called Internet of Things. Facebook Messenger, if anybody used that on your mobile phone, uses this because it's a very scalable technology to do that, and it can be secured by securing this with an SSL security type connection. So a little bit in the future, but I think you're going to see more in the industrial space with technologies like this. If you'd like to know more, it's mqtt.org is a good place to go for that. So a little bit to look forward to. Next tip, on tip number 2, it's and especially been a challenge. In my career, I've seen things start with serial. Now we're with Ethernet and all these wireless technologies. It's a challenge with all the protocols out there. So I think the next one is just be prepared for having to manage different protocols. A little easier with the new stuff, but if you got legacy stuff, it's a little difficult. 2 categories I think are important to think about, and I kind of broke this down into 2 areas. One is for kind of the media conversion, and when I say media conversion here, I'm talking about if you got serial-based stuff, 232, 422, RS-485, how can you get that on Ethernet? And the next part of this being the protocol conversion. If I've got things that speak different protocols, so if I've got a piece of equipment that came in from one of the suppliers that has Profinet, but I have to do maybe Modbus TCP, how can I get those to work? And we'll talk about some protocol conversion down here on this one. So let's delve in maybe to the first one a little bit. If you've got some pretty simple needs, there's a technology called a device server. Some of the IT guys call them terminal servers. And this is a great technology you can use to connect a serial device, again, 232, 422, 485, and get those to transparently tunnel that serial information over Ethernet. I like to explain that to folks as like a telephone connection, right? You can pick up your mobile phone or a desk phone, and you can call anywhere in the world. And as long as you both speak the same language, you can carry on a useful conversation. And this technology works just like that. Here's kind of a little example of what they might look like, a deck of playing cards or like a little DIN rail mount box like this. And these 2, you can kind of basically use that for a serial extension cord across the plant floor over a wide area network. I've done applications that span across the globe with this type of technology. But it doesn't really care about the bits and bytes that go in between, in a neat little technology. Also with this, if one of these ends happens to be a personal computer, you can put software on that PC to emulate one of the boxes up there and basically fool that PC into thinking it has a serial port when in fact it's talking via Ethernet for that. Here's another example of that. Now let's kind of shift gears from just that general purpose, just move it across from serial to Ethernet technology, another technology we call a industrial Ethernet gateway. And I'm abbreviating here a little bit just because of our time constraints today, but there are a couple different ways to move information with different protocols. I think I highlighted on the previous slide, if you've got a PLC, you can write some code in your PLC if you're good at ladder logic or doing that with function blocks to move bits and bytes around for that. If you're good, it can be pretty quick, but some of us folks aren't really good at that, and it's a little bit of a challenge. You can go out to a third party, buy a plug-in third-party module to drop in that PLC rack to give you that other communications protocol that's maybe not native for your specific vendor for your PLC on that. I've seen some folks in past years put an embedded computer in the panel and use that computer as a means to do protocol conversion. I think of all those options, I think this is a great one to think about, is this idea of having a gateway that fits in there, and basically this uses a shared memory concept to be able to make both devices talk so that you don't have to really make changes on either side other than the memory addressing to do that. And to give you a little better idea, let me go to the next slide and show a little bit about how that might work. So in this example, let's say we've got a SCADA system over here, or your HMI system that you have predominantly, you have most of your devices on Modbus, and you got this one odd box over here on Ethernet IP that you'd like to get talking with it, right? So you put the gateway in between, and basically the way this works is on that gateway, the gateway is going to have a little mini PLC polling cycle. So you'll tell the gateway, I would like to read this block of addresses in that PLC, and you're going to send the request. It's going to get turned around in the PLC, and it'll come back, and you'll put that into an image table. A little bit like a PLC, you know, output images, input images. So real simple to find, fill in the blanks. This number of registers I want starting here, and I want to do this every 100 milliseconds or every 3 minutes. And you'll build that. And what it does is it holds inside of that gateway an image table. So now the SCADA system wants to know something. SCADA system sends a request. It's refreshed out of the data table and then comes back just like that. So again, if you don't know about these, a nice little trick to have in your bag of tricks, doing remote monitoring, even plant floor applications with this type of technology to consider, in addition to some of the other technology that I talked about before. So that's the industrial Ethernet gateway for you there. Let's go take a look at another technology here, or at least another maybe a challenge. Or the tip number 3, and that is, we all try to design perfect networks, and a lot of the stuff that you see on the exhibit floor here today, there's some great tools out there to really make your job easy, and the latest generations really do a great job for that. But even in the best planned networks, there's always a little bit of a problem, when you least expect it. So I think in a good design, you want to plan for Murphy, because expect the unexpected. So expect those disruptions. So let's talk about a couple categories of that, and in this I've got a bunch of little tips, and I think there'll be something for everybody here. The first one might be in a smaller remote monitoring system. If you can have a backup media connection, this is a great thing to do. So we're talking about maybe having Ethernet out to some equipment, or maybe having maybe a little beyond the scope of Ethernet. Remember, Ethernet goes about 300 feet max. It can be a little less, a little more. Your mileage may vary on that. You might do fiber on that. One of the ways in which you can do this is to have a ring in your topology here. So this utilizes a managed Ethernet switch. Managed Ethernet switches, if you're not using them now, you should be. This is one of the good reasons to do that, because traffic in can get, with unmanaged switches, there's no control over the traffic, and you can get a loop of traffic, kind of like the traffic circle outside the building here. You can get in the traffic circle and you can't get out. And the managed switches are able to monitor the traffic and block things and get them out of the network for you. So the concept here is that if you have a network break here and the solid lines are the active communications path, if this gets disconnected, or maybe this switch here gets a circuit breaker tripped and you lose power to that switch, the net effect is that you can have a backup path up here that turns on to restore communications. So this is where that secondary backup network is really important. Some of you are probably already doing this type of thing. Let's go a little further. When you get a little beyond where it's capable or practical to do copper cabling, and I did want to mention there is one other technology that's kind of interesting. It's new. Just to come back for a second. If you're stuck and you need to get Ethernet a little further, there is a technology called DSL, like digital subscriber line, that you can run Ethernet over a twisted pair of wires. There's a little inner one that if you want to know more about that, see one of us over at Mox, so we could tell you more about how to do that. That's kind of the in-between going from wired to wireless on here. When you get into the wireless world, and when I say wireless, we're talking about a microwave link, we're talking about Wi-Fi, we're talking about probably cellular, maybe satellite. I guess with the exception of the Wi-Fi solution, most of these, cellular, satellite, have some sort of a monthly operating expense tied to them. And some of the challenges you have for these are, signal coverage. If I want to put it out at this site out here, do I have signal? Is it a good signal? Is it a bad signal? You might need to think about things such as an external antenna and maybe a mast to put that antenna on to get it high enough above physical obstructions nearby on that. And the service fees, I think, are the most important one. Now, if you're just doing one site, it's maybe a little more challenging, but as you scale up a little bit, there are plans that you can get to share data, like a family plan on your mobile phone, where you can kind of have some devices use more or less each month. But it's something you have to take into effect in designing your systems, that you're going to have to pay monthly for those services on that. If you're doing cellular, let's kind of delve into cellular a little bit for the next couple of slides and look at this. Within cellular, it's not a perfect world. It's not like having a Cat5 cable plugged in and you can just be guaranteed communications are going to happen as long as it's plugged in. You know, there's always things that change a little bit. In some busy environments, the cellular carriers are known to redirect their signal based upon ebb and flow of traffic. If there's in a corridor where there's people driving down a highway, for example, you know, there can be signal disturbances, there can be outages, you know, some of the things to plan for the unknown. So it's not as easy as just plugging it in. So one of the things you want to look at is making sure that if you do lose a connection that you can rapidly restore that, and you do that automatically. So the good devices that handle this on a cellular level have some automatic connection management. And these might be something like this where, you know, it sees that you've lost a connection and tries to reestablish at the connection level. And then maybe if that doesn't do it, it could be something that you might want to do something more severe to maybe reset the device itself, whether it's a cellular modem or a cellular I/O module for that, right? So good technology might look something like this to have that safety net or multiple safety nets, which prohibits or makes sure that you don't have to have somebody jump in the truck, you know, grab the bag and go out and, you know, reset something and reboot it by hand. So nice thing to think about to have a well-efficient systems on that. Maybe a more common one is to plan for the unexpected when there's a carrier issue. So it's really great that we're starting to converge on LTE or 4G as kind of the emerging standard for doing remote connectivity. And it amazes me, I'm traveling this week and, you know, with my mobile phone and hotspotting from the capabilities you have nowadays with 4G. But, you know, the carriers do have their little hiccups from time to time. So a good plan is if you are going to use cellular, is plan on maybe having 2 carriers for the site, right? And that works with something like this right here, where the device actually carries 2 SIM cards, and you're provisioned for both networks. And maybe you really want to stay on AT&T for this site, most of it, and that's your primary carrier. But if for some reason that you'll lose that connection, if this is a critical site for you, that you have a backup to Verizon to be able to back up to that. So real simple concept, but it's one of those things early in your studies of what you're looking to do for remote monitoring. It's a good technique to be able to have this where you have this automatic backup. And then, you know, let's say the AT&T is your primary, comes back up, you can drop the connection to Verizon and bring this one back up. So nice to have to give you more resiliency in your network as you're planning that. Let me touch on a couple more, and these aren't necessarily for cellular, just a couple of things. I know a lot of us have a lot of different things to support and some legacy infrastructure. One of the things that we see are serial devices out there. You know, things that might be PLC programming ports. They might be a flow computer if you're doing oil and gas. They might be an RTU doing Modbus. In some of these, when you've got the real simple protocols, and one of the applications I've seen this used a lot is in oil and gas, where they've got telemetry streaming off of a wellhead or off of a drilling site, and they have a problem where they lose their satellite link when a big thunder shower comes through, right? That happens. It's not perfect technology. Data buffering can be useful in those applications. So if you've got the right hardware to support this, you can, if you've lost your communications path, your connectivity device is able to keep grabbing that data and store it and hold it, and when the network comes back up, to unspool and push that data back up to your server to capture that. So basically, you do lose the direct connection on that, but as soon as the connection comes up, you don't lose any data. So this is kind of a nice way to do that. And most devices that do this will have, you know, some capability built into the device. Here's an example of Ethernet to serial. Here's a Wi-Fi to serial that does the same type of thing. We actually have a lot of applications on shop floors with this, where you've got automatic guided vehicles, or you've got mobile scales that move around on a plant floor that maybe move around, and you have to go from one AP to another. And if you need a little more storage, you can typically use like an SD card to expand that storage. Some common things to see in this type of hardware for this guy. Okay, last one, and maybe a little more common for a lot of folks, is, you know, data logging. If you have an application and you're really concerned about that data, you know, you might want to do a data logging operation here. And maybe that's possible. Maybe you've got a PLC and the extra capacity in memory to store that. That's one way to do it. Maybe you've got just some simple I/O and you want to add it. You know, this is a way to do that. And basically the concept being that you've got provisions in this device to be able to not only have a direct connection when you've got live data, but maybe to be able to store that inside of the device. And then once that connection comes up, to be able to do that. And maybe that's important to put a date timestamp in it. So there are categories of devices out here that can be kind of smart connected I/O like this that can do data logging for you when you've lost your primary connection. Or if you're in intermittent connections where the connections come and go, which unfortunately happens in some applications. Lastly, and this is maybe more from a safety perspective and from economic perspective, if you've got process or a product that's really vital and you want to make sure you don't have any loss, is to have that local control, right? A lot of times you'll have a PLC in these applications where it's really critical, but this is important to think about. So if you do lose your primary communications path, how are you able to make sure that the system shuts down safely? Or how are you able to make sure that that system is able to continue functioning if it's had a loss of communications? Or to do some sort of protective type of thing. So again, designing these systems, think about what do you need to do if you've lost communication? How do you want to handle that? And does it need to have some type of autonomous types of control here? So if you've got that in a PLC, great. If you don't, maybe you might add one of these smart relays to your application. Or maybe if you're doing a new system, there's kind of a category of smart relays that have Ethernet built into them or wireless connectivity that you can put something like these in place. And if you're not a PLC programmer, don't let these intimidate you. Some of these can be programmed off the front keypad with a display. Or with Windows-based programming software, and some are even just simple if-then-else style programming that you can say, if this digital input turns on and 5 seconds have elapsed, then do this. So you don't have to be a rocket scientist to do some of this stuff. Okay, let's move on, and hopefully a good tip here for everybody in this. I want to talk just for a few minutes about security, and I think there are a couple sessions later today that we'll kind of delve into that in a couple areas. And when we talk about connecting devices, I think there can never be too much security in this, particularly with how we've got multiple people doing multiple things on our networks today. Whether that's an in-plant network, whether that's between buildings, or maybe a wider area network amongst multiple plant facilities, maybe across different states. So really important on this, and I know this is one of those tougher issues, but maybe I can give you a couple ideas on security, how to approach it, and how to work with that. I really like this quote, and the fellow here, Bruce Schneier's been a analyst and in the area, more an IT type of guy, and his quote is, basically, security is not something that you buy, it's something that you must get. And what he's trying to say here is you just can't buy a box and then put on your network and instantly it's secure. There's a lot of individual pieces. And I think for myself and probably a lot of you here, that's kind of a challenging thing because it means it's training for people you work with, it's processes, it's audits, and a couple of things. And I think as you're thinking about this, keep that in mind as you go through it. But at the same time, there are also some technologies that you can employ that will help you tremendously on that. So I think this is a good way to kind of set the tone for this. One of the topics you'll hear a lot, maybe you probably already heard this, is this defense in depth idea. And that is by being able to break things up into zones and to compartmentalize things. A little bit like if you've got a marine vessel, right? They have the safety doors, and if you've got a leak, they want to close the compartments and make sure the whole ship doesn't sink. That's kind of the same analogy with this here. And while not officially part of this, I did want to just spend a moment here to talk about this whole life cycle process. I like that quote before. It's not that you just install it and it works forever. You continually have to monitor what you're doing and periodically audit your network and do things. And this is really where, if you're a controls engineer or a tech or whomever, you really want to get to know your IT guys and you want to kind of cross over on this. I spent some time in the data center and learned so much from the IT guys, you wouldn't believe it. And they learned a lot from me about what it's like to maintain real-time response times on the shop floor. So it's really important, and you just can't forget that. The other aspect, and this is a little bit of a look at how do you compartmentalize that. I could probably, and there's probably others that could do a better job than me, spend a couple hours just talking about this one diagram. But the key takeaways for you is to be able to break your system down into little pieces, and you want to do that by information flow. And you want to find out, what are the logical zones for information flow based upon maybe a control level at your shop floor level or at your remote site level, and what's the information that has to flow amongst these zones. And that will help you kind of put your strategy together. And once you're able to identify the information that flows between the zones, then you can kind of start to put your strategy together on this. So this one's a little bit busy on the slide, and there's a lot here, but I think if you can think about compartmentalizing things like the naval vessel, and then thinking about those bulkheads with safety doors, and being able to have a guard at those doors saying who can come and go, that will really help you a lot to have some basic concepts of security on here. Let me take a super oversimplified application for like a pipeline monitoring application, give you a little bit of a sense of that. Often these applications have from the control room out to the individual sites, a network. Typically that's a private network. You wouldn't typically run this over the internet. But I just wanted to show you here that you typically are going to have different zones of control here. When you get out to a field site, one of the key fundamental elements that we want to have here, and I'm going to spend a few minutes talking about firewall and VPN technology at the 35,000 foot view for you guys, because they're a little bit bewildering if you dig into them too much. But to show you, the practical use of those technologies and how it fits into a system like that, these are truly important things that help you to segment that traffic and then still have secure remote access to it. So if you don't know about firewalls, they play kind of an important function here. They work like a security cop on your network to basically allow traffic or not allow traffic. And I'm going to spend just a few minutes just at a high level talking about it. So on the left-hand side here, you have your unsecure zone, maybe outside the protected area. And not that it's unsecure, but it's less secure than over here on the right-hand side in your secure zone over here. And basically the purpose here is probably to block everything that wants to come in and maybe allow traffic from the inside going out. Maybe like at your office, or maybe if you have a home office where you have your router that connects you to the internet, you want to be able to get out to maybe send an email or maybe Skype with a friend or family member, and also to do that. The firewall lets you set this up, and there's a lot of interesting technology on the types of things you can filter on, which is really, really great. You'll hear things like layer 2, layer 3, layer 4. This is just talking about at what level in the network you're going to filter on. And I like to kind of summarize this. This is at the Ethernet level, at the IP level, and the TCP packet. I'll talk about this like intermodal cargo containers. You'll see these on a ship that comes from overseas. That cargo container is up here, and kind of like that's at the Ethernet level, the big cargo container. Inside of Ethernet is maybe individual pallets or boxes. That's at this level. And then when you get down to the next level that's the box inside the carton. So this is this compartmentalization of this that you can filter based upon those things. So sometimes you might want to know about individual MAC addresses on the shop floor, which is the physical Ethernet address. Other times you may want to know more about, hey, what's the IP address or a port number for that? When you do this on your firewalls, this is kind of what you do at a high level is a basic application. You basically have a short little table like this called policies, and the policies allow you to set permissions. The basic thing would be deny anything trying to come into my local area network. Allows nothing. However, if you have a SCADA system that's doing Modbus TCP, port 502 is used for communications, there may be a need that you might want to add a rule into this that allows incoming requests on port 502 to see what's happening at that site. So I think you get to see here a little bit the power of what you can do with firewalls to control traffic, and again at that high level of this. So again, deny everything and only allow what you want to come in. You can also do this the reverse method, and you can say you can't let anything on the inside get to the outside as well. The reason for this might be, What happens if this is a site that can have service technicians in and you could get, a virus on side of one of your industrial PCs and that goes out to the internet and pulls something bad down? One of the things you might do is block port 80 access out to the outside world to prohibit that type of thing. Okay, and then another thing here, there are a couple categories of firewalls here. I won't spend a lot of time, but there's a routed mode which is more typical, that you basically have a outside IP address and inside. Good example of this might be your router at home. You might have 192.168.1.50 for your laptop, and externally you might have something like a 10.1 or a 172 dot on your outside address. Some applications, particularly for legacy applications, where you've got to upgrade it, but you don't want to re-architect and change your IP addresses, there are ways to install a firewall in here without changing the IP addresses on those, and we call that a transparent mode. Again, if you'd like to know more, there's some great resources, and again, I've learned a lot of this from working with IT people on this. The other thing here, real briefly, and I'm just kind of go through this a little quick, is VPN technology. Probably a lot of you already use this. If you're out of the office and you need to be able to access something or you need to get on your email, use VPN technology. This can be a secure way to get in through your firewall to do that. So we're showing here, where you might do that as a user on your laptop, like me as I'm traveling this week. You can also do that to set up these virtual point-to-point connections. So this can be a very good way to have remote maintenance access to a site. And you can also do another mode of access where you can do site-to-site connections here as well. There's a lot to set these up, and don't let that intimidate you. Some of the things when you're doing this is know a little bit of the buzzwords. Some things, and this is kind of the key things, if you just look at the major bullets on here, is being able to have that secure connection over an untrusted network, right? To make sure that only the authorized people are able to access this. To make sure that you can't have a man-in-the-middle attack. This is where somebody can intercept communications and kind of make it appear not what it should be to ensure your data integrity. And lastly, to encrypt that data. Right? Maybe you've got a proprietary process and you don't want anybody to see what's happening. VPNs can do encryption as well for this type of thing. And then lastly here for VPN is here's that remote access where you can get into those remote sites. Also your site-to-site configurations. Site-to-site's one of the things that's not real well known and is typically used in an IT environment for branch offices. So maybe you've got headquarters up here and maybe you've got a factory over here. You'll typically have a site-to-site VPN to connect between those two sites. Very powerful technology and lets you basically make a larger network look like one local network with that technology. Okay, hopefully I didn't get too technical on you guys and kept it high level. I hope that if you haven't worked in some of these things that you're excited to take a look and learn more about some of the technologies to make your job easier. Last one, and I'll try to get through this and take a look at this one final thing, which is kind of something that not a lot of people know about. If you're installing managed switches, for example, is to select infrastructure that you can monitor, right? So it's kind of like putting instrumentation into your system to be able to kind of fine-tune and remote monitor it on here. So this is what happens, and I know I learned this early in my career. What happens when your SCADA system says something's offline, right? Typical approach had been to, okay, I got to grab my laptop and walk down to the plant floor. I got to jump in the pickup truck and go out there and see what's happening. What happens if my PLC throws a fault and I've got remote I/O on the PLC? How do I diagnose that, right? So you can have some common problems here, and how do we troubleshoot those? Well, the IT guys do this. Some of you might know about Simple Network Management Protocol, or SNMP. I call it Modbus for the IT guys. And this is one technology IT uses, but not so friendly for us that are controls folks. And it uses the concept of a manager, kind of like the SCADA server, and then the agents are software that sit on the edge devices to do that, okay? Good that it's out there. IT's been using it for 20-some years, works real well. It gives you things like this, like system status. Do I have both my power supplies, power supply A and B working? Is Ethernet up and down? And I'm actually using kind of an Ethernet switch as an example here. On my traffic, how much traffic is going in and out of this device? And a whole bunch more. So what I'm trying to point out here is a lot of your devices, Ethernet switches, basically, those managed switches, the edge devices, even the PLCs and RTUs have this type of information inside. How do you get it out? And the typical approach has been is to use SNMP. So you might use an appliance, or you might use a OPC server over here, pulling SNMP out of the device into the OPC server, and then exposing that OPC data to something else. But a lot of new generation products actually support native protocols from the device itself. So let's say you've got that managed switch out here, and you'd like to get that up to your HMI. Well, guess what? A lot of managed switches talk Modbus TCP now. So if you wanted to have a HMI screen or a SCADA system show just some simple network health monitoring, you can see which ports are connected and which ones are not on a special screen you've designed, just adding those data addresses for those individual data devices in that managed switch over here. So you don't need to know SNMP, you don't need to know anything new, you just need to build an extra screen on your system that brings in those native addresses if you can support those protocols. The last thing here that I'll wrap up with, my last point, is once you've got these devices, don't forget about tools to manage your network, okay? And there's some really simple ways to do this. And again, this is where the IT guys have been doing this for about 20 years now. There's some fantastic tools the IT guys use. You might have seen these on the Network Operations Center with a big room like this and all the screens that they can monitor what's happening. You can do the same to whatever level you'd like to do. And basically, there are software tools out there that you can put on a PC, monitor via web browser to look at all of your infrastructure, PLCs, VFDs, whatever talks Ethernet or has a way to connect to it, and does things like this to be able to look at the topology. And let me go to the next slide. I think I can give you a little better idea here of this to look at it. So here's our plant floor network with all of our switches out here, right? So being able to visualize the network, being able to visualize which way the traffic's flowing, being able to visualize what's happening when something comes offline by colors and these types of things. Or maybe if I know I've got a problem on this device over here in the lower right-hand corner, how can I click a button and bring up a view of what that device is and what it's doing? And how about being able to capture event messages that tell me what's happening? So these three things are really powerful to you. And I'd encourage you to think about these as you're designing new systems to do this. And to finish up here on the kind of the next step of that, this is even available now on a mobile device. So on my phone here, I can run a little software application that gives me these notifications remotely. And it does that just by using normal messaging tools, whether you're on an iPhone, on iOS, or on Android. There's a messaging technique to do that you can send those critical messages. And then if you have VPN access with the right security credentials to get into your network, you can drill in and see a little bit more of that. There's many different technologies out there now to do this. From Moxa, we call this MXview, is that supervisory management software to monitor your network. And MXview Go is this latest generation to see this on your mobile phone. And it kind of is a closing, a parting thought here for you guys. You can download this from our website. It's free to use with up to 20 devices. You can use this with things other than Moxa. So if you've got other devices that talk SNMP and are able to give you data via SNMP, you can set this up and play with it. You'll need to have a PC that you can put the server software on, and you look at the rest via web browser. And of course, if you want the application here from either from Google Play or the App Store, you can get the Android app for that. So with that, I wanted to kind of close and tell you thanks for your attention. I hope that, I know a lot of you have a lot of different backgrounds today from what you do. Hopefully you were able to find a few different interesting tips or techniques to integrate into what you do. Hope they encourage you to talk to your IT brethren and work together to really take advantage of remote monitoring to increase efficiency, make it easier to do more with less, and some fun things like that. Thanks so much.